Why was this unique skull morphology only formally distinguished from other contemporary ceratopsids by scientists in 2010 specifically? How did isolation by the western interior seaway shape evolution on the southern portion of ancient Laramidia? Could dental batteries designed for shearing tough vegetation allow efficient processing of fibrous plants in humid floodplains? Why did adults possess a thickened nasal boss structure instead of a long nasal horn weapon at all? Did large hornlets curving forward along the margins create a distinctive silhouette used for species recognition and display? Do all known fossils originate from the Kaiparowitz Formation, preserving a snapshot of late Cretaceous ecosystems intact? How did the genus disappear locally long before the global mass extinction event ended the Cretaceous period? Don't miss what comes next in this story. Watch to the very end.
Hello, I am Jonny Dony, and this channel brings you dinosaur documentaries grounded in real paleontological science and evidence always. We explore Utahceratops in lost horns of the southern floodplain. So please like this video and subscribe for more content.
Lost horns of the southern floodplain. The farther backward you can look, the farther forward you are likely to see. Winston Churchill. Utahceratops Origins. Warm air hangs heavy over vast wetland floodplains stretching toward the horizon. The sun beats down on dense vegetation covering the ancient southern landscape. 76 million years ago, within this humid ecosystem, a distinct lineage emerges from the evolutionary shadows now. Adults reach significant size with robust bodies supported by sturdy limbs. They move with quadrupedal grace across the soft mud of the high water table. This large herbivorous dinosaur dominates the specific ecosystems of southern Utah during this period fully. The environment consists of wetland floodplains with high water tables and dense vegetation. Diverse flora, including conifers, supports a complex biological community within the region. This ecosystem hosts numerous other dinosaur species, creating a highly competitive biological community here today. As herbivores, they utilize sharp beaks and dental batteries to process tough plant material. They browse on low-growing vegetation such as ferns and cycads found throughout the wetlands. Complex jaw mechanics allow for efficient shearing of fibrous botanical matter effectively daily. Adults reach approximately 6 meters in length and weigh around 2 metric tons. Their bodies are robust and quadrupedal, supported by sturdy limbs adapted for heavy weight. This massive frame requires substantial food intake to sustain daily metabolic functions well. Utahceratops gettyi was formally described by Scott Sampson and colleagues in 2010. This distinction relies on unique skull morphology found exclusively within Utah during the late Cretaceous. It separates this genus from other contemporary ceratopsids based on cranial features found. Fossils originate from the Kaiparowitz Formation, representing a specific window in dinosaur evolution. These remains indicate a restricted range within the southern portion of ancient Laramidia. No specimens have been discovered outside this specific geographic region currently known today. The isolation created unique evolutionary pressures on the population living in this specific region. They lived alongside other contemporary dinosaur species, inhabiting the warm floodplains and dense vegetation. This separation defines the unique evolutionary path within the family Ceratopsidae there. The skull was massive, featuring short brow horns and a distinct nasal horn. Strong neck muscles supported the heavy skull, which featured this thickened nasal boss structure. Distinctive features include large hornlets on the frill margins and a unique nasal boss. The frill was relatively short compared to other chasmosaurines living in the same geographic region. Large hornlets on the frill margins facilitate species recognition and potential defensive capabilities. These adaptations protect against contemporary predators hunting in the area effectively now. Evidence suggests gregarious behavior, though direct herd evidence is limited compared to northern relatives. Intraspecific combat likely occurred using horns for dominance displays during mating seasons. Juveniles may have occupied different ecological niches than adults to reduce competition here. The climate was warm and humid, supporting diverse flora, including conifers and flowering plants. This ecosystem hosted numerous other dinosaur species, creating a highly competitive biological community. Survival demands strict economy of precious energy and effort in this landscape always. This species represents a unique evolutionary path within the family Ceratopsidae during this specific window. It challenges previous assumptions of uniform dinosaur distribution across North America entirely. The discovery underscores the importance of the region for understanding biodiversity fully. It disappeared during the Campanian, millions of years before the end Cretaceous extinction event. This local extinction suggests environmental changes or competition rather than the global asteroid impact. The genus vanished locally long before the global mass extinction event occurred. This genus highlights the high diversity of ceratopsids in southern Laramidia before the end. Scientific study of remains allows detailed understanding of late Cretaceous biodiversity and evolutionary patterns. The fossil discovery underscores the importance of the specific region for understanding. I confirm Utahceratops was formally described in 2010 based on unique skull morphology. Record your observation on this distinct evolutionary lineage below. Hit like and subscribe to support my detailed scientific investigation. The next chapter shows the restricted range within Grand Staircase Escalante boundaries. Southern Habitat Range. Heavy footsteps crush the soft mud of the floodplain edge constantly here. This massive herbivore moves slowly through the dense undergrowth seeking fresh browse daily. Its geographical range is strictly limited to this specific southern basin alone, entirely within boundaries. Fossils remain exclusively within the Grand Staircase Escalante National Monument boundaries today precisely. These remains indicate a restricted range within the southern portion of the ancient island continent. No specimens have been discovered outside this specific geographic region currently known to science. The isolation created unique evolutionary pressures on the population living in this specific region constantly. They lived alongside other contemporary dinosaur species inhabiting the warm floodplains daily here. Dense vegetation throughout the entire Campanian age covered the landscape completely then. This species inhabited the southern portion of the ancient island continent Laramidia exclusively. It was isolated from northern populations by the western interior seaway during the late Cretaceous period. Water separated these groups for millions of years, effectively always. Ancient seas divided the landmass into distinct northern and southern ecological provinces permanently. Movement between these regions was impossible for large terrestrial animals like this herbivore. Genetic exchange ceased completely, allowing distinct lineages to develop independently over time slowly. Paleontologists study the rock layers to understand where these animals lived and died specifically. The Kaiparowitz Formation preserves a snapshot of late Cretaceous ecosystems within the monument boundaries. Scientific study of remains allows detailed understanding of late Cretaceous biodiversity patterns. High water tables maintain the lush wetland environment necessary for such large herbivores constantly. Conifers and flowering plants provided abundant food sources throughout the warm, humid climate always. This ecosystem hosted numerous other dinosaur species, creating a highly competitive biological community. Adults reached approximately 6 meters in length and weighed around 2 metric tons fully. The body was robust and quadrupedal, supported by sturdy limbs adapted for heavy weight. Strong neck muscles supported the heavy skull, featuring distinctive anatomical adaptations clearly. Distinctive features include large hornlets on the frill margins and a unique nasal boss structure. The frill was relatively short compared to other chasmosaurines living in the same region. These adaptations facilitated species recognition and potential defensive capabilities against contemporary predators hunting. Evidence suggests gregarious behavior, though direct herd evidence is limited compared to northern relatives. Intraspecific combat likely occurred using horns for dominance displays during mating seasons annually. Juveniles may have occupied different ecological niches than adults to reduce resource competition. As a herbivore, it utilized a sharp beak and dental batteries to process tough plant material. It likely browsed on low-growing vegetation such as ferns, cycads, and early angiosperms found. The complex jaw mechanics allowed for efficient shearing of fibrous botanical matter effectively. However, environmental changes or competition caused disruption within the region, eventually over time. Utahceratops represents an endemic lineage, evolving in isolation on southern Laramidia completely. It disappeared during the Campanian millions of years before the KPG Extinction Event. This local extinction suggests environmental changes or competition rather than the global asteroid impact event. This genus highlights the high diversity of ceratopsids in southern Laramidia significantly always. It challenges previous assumptions of uniform dinosaur distribution across North America entirely. The fossil discovery underscores the importance of the specific region for understanding fully. Late Cretaceous biodiversity and evolutionary patterns within the specific boundaries are revealed clearly. Scientific analysis provides crucial insights into the history of these ancient animals now. The Western Interior Seaway defined the limits of their world completely and absolutely. Survival depended on adapting to the unique pressures of this isolated southern landscape daily. Their legacy remains buried within the stone of the Grand Staircase forever. Could isolation alone drive such unique evolutionary changes within this specific southern basin? I found the western interior seaway created distinct pressures here. Please like and subscribe to support my research efforts. Next, I reveal how their dental batteries processed tough vegetation daily. Feeding mechanisms. The massive head lowers slowly toward the dense undergrowth covering the wetland floor. A sharp, keratinous beak snaps shut on a cluster of fibrous ferns with precise mechanical efficiency. This initial cropping action separates tough stalks from the rooted base instantly. Muscles along the jawline contract powerfully to drive the lower mandible against the upper structure. Force is distributed evenly across the broad surface area of the skull during this movement. Such strength is required to crush resistant plant matter without damaging bone. Inside the mouth, rows of tightly packed teeth form a continuous grinding surface known as a battery. Hundreds of individual replacements wait beneath active units to maintain functionality throughout the animal's life. This complex system ensures uninterrupted processing capability during daily feeding cycles constantly. Dental batteries contained numerous tightly packed teeth designed for shearing tough vegetation effectively within the habitat. Efficient processing of fibrous plants available in the warm, humid floodplain environment sustains massive bodily functions. Without this adaptation, survival in such competitive biological communities would be impossible. Low-growing vegetation such as ferns and cycads provides the necessary caloric intake for growth. Early angiosperms found throughout the wetland floodplains offer additional nutritional value during dry seasons. Variety in diet prevents depletion of any single resource patch locally. The tongue manipulates cropped material toward the dental surfaces for thorough mechanical breakdown before swallowing. Saliva mixes with shredded plant fibers to begin chemical digestion within the gut cavity. Every calorie extracted counts toward maintaining the heavy body mass daily. Adults reached approximately 6 meters in length and weighed around 2 metric tons, requiring food. Substantial food intake is needed every single day to support such immense physical bulk constantly. Starvation remains a constant threat if vegetation becomes scarce due to drought. Competition for resources is fierce among the numerous other dinosaur species inhabiting the region. Herbivores must consume vast quantities simply to maintain energy levels against potential predators nearby. Efficiency in feeding allows less time exposed to danger while browsing openly. Juveniles may have occupied different ecological niches than adults to reduce resource competition within population. Smaller individuals browse higher vegetation inaccessible to larger, mature members of the same species. This separation ensures sufficient food availability for all age groups surviving here. Strong neck muscles supported the heavy skull, which featured this thickened nasal boss structure prominently. Stability is crucial when pulling down resistant branches or stripping bark from sturdy trunks. The head acts as a counterbalance during these vigorous feeding movements constantly. Wear patterns on fossilized teeth reveal the specific types of abrasive plants consumed regularly. Silica-rich horsetails leave distinct microscopic scratches on the enamel surfaces over time. Science reads these marks like a menu from millions of years ago now. Seasonal changes alter the availability of preferred browse across the vast floodplain landscape dramatically. During wet periods, Lush growth supports peak population densities throughout the entire basin area. Dry spells force migration toward remaining water sources and concentrated vegetation patches. This dietary specialization enabled the species to thrive in a highly competitive biological community. Adaptation to local flora defines the evolutionary success of this endemic lineage completely. Failure to adjust feeding strategies would result in rapid population decline quickly. However, environmental changes or competition cause disruption within the region, affecting food sources significantly. Shifts in plant composition may have outpaced the ability of the animal to adapt. Specialization becomes a liability when the specific required resources disappear entirely. The genus disappeared approximately 75 million years ago, vanishing locally long before global mass extinction. Local extinction suggests environmental changes or competition rather than the global asteroid impact event. This highlights the high diversity of ceratopsids in this region before the end. While earlier chapters mapped its habitat, this one reveals how it survived daily. I show that dental batteries powered this massive herbivore effectively. Subscribe to track every evolutionary adaptation I uncover here. Next, I examine the unique nasal boss structure, distinguishing it from relatives. Nasal structure. A massive skull lowers through the dense ferns, brushing against thick vegetation with deliberate care. The prominent nasal structure dominates the facial profile, presenting a thickened boss rather than a sharp projecting horn. This robust feature anchors powerful muscles required for supporting the heavy head. Strong neck muscles support the heavy skull, which featured this thickened nasal boss structure continuously. These adaptations facilitated species recognition and potential defensive capabilities against contemporary predators hunting in the area. The morphology distinguishes it from relatives like Pentaceratops, which retained longer nasal weaponry. Unlike its northern cousins, this creature evolved a blunt projection suited for close-quarter pushing matches. Distinctive features include large hornlets on the frill margins and a unique nasal boss structure on the skull. The frill was relatively short compared to other chasmosaurines living in the region. Visual signals were crucial for social interactions within the dense vegetation of the habitat constantly. Intraspecific combat likely occurred using horns for dominance displays during mating seasons or territorial disputes. Juveniles may have occupied different ecological niches than adults to reduce competition. The parietal frill featured large, forward-curving hornlets along the margins, creating a distinctive silhouette. This shape was used for species recognition and display among competing dinosaurs in the region. Such ornaments signaled maturity and status to potential rivals nearby. Evidence suggests gregarious behavior, though direct herd evidence is limited compared to northern relatives. Groups likely moved together through the wetlands for protection against large carnivorous threats lurking nearby. Juveniles may have occupied different ecological niches than adults to reduce competition. This genus highlights the high diversity of ceratopsids in the region before the end. It challenges previous assumptions of uniform dinosaur distribution across North America entirely. The fossil discovery underscores the importance of the specific region for understanding biodiversity. Utahceratops represents an endemic lineage evolving in isolation separated by the western interior seaway. It disappeared during the Campanian, millions of years before the end Cretaceous extinction event. This local extinction suggests environmental changes or competition rather than the asteroid. All known fossils originate from the Kuiperowitz Formation, a geological unit preserving a snapshot. The discovery underscores the importance of the Grand Staircase Escalante region for understanding late Cretaceous biodiversity. Evolutionary patterns within the specific boundaries reveal unique biological histories. The environment consisted of wetland floodplains with high water tables and dense vegetation supporting. The climate was warm and humid, supporting diverse flora including conifers and flowering plants. This ecosystem hosted numerous other dinosaur species, creating a highly competitive community. Adults reached approximately 6 meters in length and weighed around 2 metric tons. The skull was massive, featuring short brow horns and a distinct nasal boss. The body was robust and quadrupedal, supported by sturdy limbs adapted for weight. Powerful neck musculature anchored the massive head to the sturdy vertebral column effectively. Distinctive features include large hornlets on the frill margins and a unique nasal boss. The frill was relatively short compared to other chasmosaurines. These adaptations facilitated species recognition. Instead of a long nasal horn, adults possessed a thickened nasal boss structure. This distinguishes it from relatives like Pentaceratops, which retained longer nasal weaponry. Such structural differences indicate specialized evolutionary paths within the broader ceratopsid family tree. Survival depended on adapting to the unique pressures of this isolated southern landscape daily. Their legacy remains buried within the stone of the Grand Staircase forever. The western interior seaway defined the limits of their world completely and absolutely. This highlights the high diversity of ceratopsids in the region before the end. Scientific study of remains allows detailed understanding of late Cretaceous biodiversity. The fossil discovery underscores the importance of the specific region for understanding. This nasal boss hints at complex social behaviors hidden in the vegetation. My analysis shows these structures facilitated crucial dominance displays during mating. Like and subscribe to support this detailed paleontological investigation. Next, I reveal how frill ornaments dictated survival through visual signaling. Frill displays. Large forward curving hornlets line the margin of the massive parietal frill with striking precision. These bony projections create a distinctive silhouette against the dense background vegetation of the floodplain. Such anatomical features serve purposes far beyond simple physical defense against hunting predators. Visual signals prove crucial for social interactions within the thick greenery covering the warm, humid landscape daily. Recognition between individuals relies heavily on the unique shape formed by the ornate cranial structures. Mistaken identity could lead to unnecessary conflict or wasted energy reserves quickly. Evidence suggests gregarious behavior among these heavy browsers, though direct herd evidence remains limited compared to northern relatives. Groups likely formed loosely around available resources, rather than strict migratory patterns seen elsewhere. Survival depended on maintaining contact within the visually restricted environment constantly. Intraspecific combat likely occurred using horns for dominance displays during mating seasons or territorial disputes within the population. Males would lock heads to test strength without inflicting lethal damage to potential breeding partners. Ritualized aggression ensures genetic fitness without compromising the stability of the group. The heavy skull requires strong neck muscles to support the weight during these intense physical confrontations between rivals. Power is demonstrated through pushing matches rather than slashing attacks typical of other contemporary grazing animals. Endurance often decides the victor in these contests for reproductive rights. Juveniles may have occupied different ecological niches than adults to reduce resource competition within the population significantly. Younger individuals avoided direct conflict with fully grown counterparts possessing massive weaponry and experience. This separation allows the next generation to mature without excessive mortality rates early. Distinctive morphology distinguishes this genus from contemporaries, possessing different cranial structures for defense against large predatory threats nearby. The short frill compared to other chasmosaurines highlights specific evolutionary pressures present within the isolated population group. Adaptation drives form to meet the specific demands of the local environment. Display behavior maximizes visibility of the ornate frill structure when challenging competitors for access to fertile mates. Bright coloration might have adorned the bony margins during peak breeding seasons to attract attention. Visual prominence signals health and vitality to potential partners observing from nearby shadows. Communication through posture prevents escalations into dangerous physical fights that could injure valuable members of the community. A lowered head presents the full spread of the frill to intimidate approaching rivals effectively. Submission is signaled by turning away before contact is actually made between bodies. The dense vegetation of the wetland floodplain necessitates clear visual markers for identifying friends from foes instantly. Sound travels poorly through thick conifers and flowering plants covering the ground layer extensively. Sight becomes the primary sense for maintaining social cohesion among the massive grazing animals. Scientific analysis of skull variation reveals subtle differences, indicating distinct roles within the social structure of the herd. Older individuals display more worn hornlets, suggesting frequent participation in dominance rituals over many years. Experience grants status within the complex hierarchy, governing daily movements and feeding. Environmental changes or competition cause disruption within the region, affecting social structures and breeding success rates dramatically. Shifts in available habitat might have forced closer proximity between groups, increasing frequency of aggressive encounters. Stress levels rise as resources become scarce during prolonged dry periods annually. This shape was used for species recognition and display among competing plant-eating dinosaurs in the region exclusively. Hybridization with other ceratopsids is prevented by these clear morphological boundaries visible from a distance. Reproductive isolation maintains the genetic integrity of the lineage over many generations. Survival strategies extend beyond mere physical defense to include complex social signaling mechanisms developed over millions of years. Cooperation offers protection against predators, while competition ensures only the strongest genes are passed forward. Balance between This chapter reveals the frill's hornlets served as crucial visual signals for recognition. I invite you to discuss this social behavior in the comments below. Like and subscribe to support my ongoing research into these creatures. The next chapter uncovers the specific rock layers holding these remains. Fossil location. Bone meets stone in silent embrace beneath the layered sands of the southern basin. These layers hold the complete remains of this unique endemic lineage evolving in isolation here. No other region offers such detailed scientific study of remains found within boundaries. All known fossils originate from the Kaiparowitz Formation, a geological unit preserving a snapshot of late Cretaceous ecosystems within the Grand Staircase Escalante National Monument boundaries. This restricted deposit signals a population confined strictly to this southern territory. Surrounding rock layers remain silent regarding this animal. Evolutionary pressures shape this creature uniquely within the isolated southern portion of the ancient island continent Laramidia. Separation by the western interior seaway created distinct biological communities developing independently across the fragmented landscape. Genetic exchange with northern populations was impossible across the vast watery divide. It disappeared during the Campanian, millions of years before the end Cretaceous Extinction Event swept across the continent. This local extinction suggests environmental changes, or competition, rather than the global asteroid impact event. The cause lies buried within shifting climatic patterns of the region. The genus disappeared approximately 75 million years ago, vanishing locally long before the global mass extinction event ended the period. Survival here depended on adapting to shifting resources rather than surviving a cosmic catastrophe. The asteroid struck much later than this specific population decline. Environmental changes or competition caused disruption within the region long before the final days of the age. Drying wetlands reduced available browse for large herbivores, requiring substantial daily food intake. The floodplain ecosystem contracted slowly, squeezing populations into smaller, viable habitats over time. Competing herbivorous dinosaurs occupied similar ecological niches within the highly competitive biological community existing inside the region. Resource scarcity intensified pressure on adults reaching 6 meters in length and weighing around 2 metric tons. Survival required navigating shrinking territories without adequate food sources. This genus highlights the high diversity of ceratopsids in southern Laramidia, challenging previous assumptions of uniform dinosaur distribution. Unique morphological features distinguish this lineage from relatives living in different ecosystems during the time frame. Variation proves isolation drives significant evolutionary divergence over millions of years. The discovery underscores the importance of the Grand Staircase Escalante region for understanding late Cretaceous biodiversity and evolutionary patterns. Paleontologists study these rocks to reconstruct ancient biological communities preserved in stone. Each fragment reveals a piece of the complex ecological puzzle hidden underground. a geological unit preserving a snapshot of late Cretaceous ecosystems within the Grand Staircase Escalante National Monument boundaries offers clarity. Time stops within these sedimentary layers, capturing life exactly as it existed before disappearance. The rock holds secrets of a world lost to deep time. Utahceratops represents an endemic lineage evolving in isolation on southern Laramidia, separated by the western interior seaway. Such isolation fosters unique traits not seen in contemporary populations living further north. Evolution proceeds differently when populations remain cut off from external genetic influence completely. No specimens have been discovered outside this specific geographic region currently known to paleontologists studying the area. The silence of the surrounding rock layers speaks volumes about the limited range of this animal. Boundaries were absolute for creatures unable to cross the sea. Fossils originate from the Kaiparowitz Formation, representing a specific window in dinosaur evolution before the end arrived. This time frame places it well before the end Cretaceous extinction event eliminated non-avian dinosaurs globally. The window closes slowly as environmental conditions shift against the population. Their legacy remains buried within the stone of the Grand Staircase, waiting for scientific study of remains. Detailed understanding of late Cretaceous biodiversity and evolutionary patterns emerges. While earlier chapters detailed physical features, this one reveals restricted fossil locations. I confirm this lineage vanished locally before the global extinction event occurred. Like and subscribe to track the full scientific narrative closely. The next chapter shows rapid morphological shifts during final, desperate years. Extinction Event. Morphological shifts appear rapidly within the fossil record during the final generations. Horn orientation changes subtly as populations struggle against shifting selective pressures across the landscape. This rapid response demonstrates a remarkable capacity for adaptation before the end arrives. Environmental conditions deteriorate slowly but relentlessly throughout the remaining years of existence here. Water tables drop while vegetation patterns change across the warm, humid floodplain regions. Resources become scarce for heavy bodies requiring substantial daily intake to survive. Competition intensifies among contemporary dinosaur species inhabiting the same restricted geographic basin entirely. New arrivals challenge established dominance within the highly competitive biological community constantly. Survival depends on securing enough food before rivals consume the available plants. The heavy skull, supported by strong neck muscles, becomes a liability rather than asset. Energy expenditure outweighs gains when foraging becomes difficult in the changing landscape. Physical adaptations, once advantageous, now drain precious reserves needed for basic maintenance. Gregarious behavior offers limited protection against these overwhelming environmental stresses facing the population. Social structures fracture as groups scatter to find isolated patches of remaining sustenance. Intraspecific combat decreases when energy conservation becomes the primary driver for existence. Juveniles occupying different ecological niches than adults fail to reduce resource competition sufficiently. The strategy works only when abundance exists throughout the warm, humid climate. Scarcity removes the buffer protecting the young from starvation during critical growth periods. Evolutionary changes occur relatively quickly in geological terms during these final desperate years. Modifications to horn orientation and frill shape happen under intense selective pressure now. The species demonstrates plasticity but cannot overcome the fundamental shifts in habitat. Populations adapt to shifting environmental conditions across their extensive North American range before catastrophe. However, local pressures prove insurmountable for this endemic lineage evolving in isolation. The capacity for rapid morphological response reaches its absolute biological limit here. The genus disappeared approximately 75 million years ago, vanishing locally long before global events. Mass extinction events eventually ended the Cretaceous period entirely for non-avian dinosaurs much later still. This local extinction suggests environmental changes or competition rather than the asteroid impact. Silence falls over the floodplains where heavy footsteps once crushed the soft mud completely. No specimens have been discovered outside this specific geographic region currently known to science today. The restricted range within the southern portion sealed the fate of the lineage. This highlights the high diversity of ceratopsids in southern regions before the end arrived. Previous assumptions of uniform dinosaur distribution across North America are challenged completely now. The fossil discovery underscores the importance of the specific region for understanding complex evolutionary patterns. Biodiversity within the late Cretaceous period reveals intricate webs of life and death constantly. Evolutionary patterns within the specific boundaries show how isolation drives unique development here. Scientific study of remains allows detailed understanding of these ancient biological communities, now forever preserved. Stone holds the final record of a lineage that could not adapt any further. Changes in horn orientation and frill shape occurred quickly in geological terms alone. The species' remarkable capacity for rapid morphological response reached its absolute biological limit there finally. Survival strategies once successful become obsolete when the environment shifts too rapidly here. Heavy bodies supported by sturdy limbs adapted for weight cannot escape changing conditions effectively anymore. The window for dinosaur evolution within this specific region closes permanently now forevermore. The story ends not with a global cataclysm, but with a quiet local fading. Evolutionary success is never guaranteed regardless of physical size or specialized adaptations possessed. Life persists only while the environment permits existence within these ancient boundaries. My exploration of Utahceratops concludes with this final local extinction event. Evolutionary success is never guaranteed regardless of physical size. Like and subscribe to support more detailed scientific documentaries on this channel. Explore my other videos to discover more prehistoric creatures preserved in stone.
I am Jonny Dony, and our journey through lost horns of the southern floodplain has concluded. Together, we explored the unique life of Utahceratops within its ancient wetland home. This distinctive herbivore thrived in isolation before disappearing millions of years ago. Your curiosity drives these documentaries, so please subscribe and leave a comment below. I extend deep gratitude to my sponsors and channel members for their continued support. Your contributions allow me to research and share these prehistoric stories accurately. In just a few seconds, 2 videos with equally interesting documentaries about dinosaurs will appear on the screen. So, go on to watch the next fascinating story.